So the most important thing is to fix the levels. And from the first building, the barn, to the second building that will be here, I need at least 3 or 4 different voids. So we have created the first one. So that's the first one where the barn is. And if we select this and edit in place, we select this void and we go to a lateral right view, we see that this level is, well, it's too far. It's this one. It's level -7. Okay, so I set the base of this void on level -7. So I have to go now down, and in this case, my level is -12. Okay, so I want something that it's 4 or 5 feet below the first void. Okay, so I go to my top 3D view, and I'm going to create another architecture component model in place. Select Toposolid and a void form extrusion. And well, I wanted to do something like this. I want an angle because I want to complicate things a little bit more. So I want the ramp to follow this this angle, and then I want to get into the previous Toposolid. I want like a 6-foot ramp, 6 foot, and then I can go this way or that way, it's better. And now I want to line up this with this staircase here. And finally, I will close this gap this way and trim. Remember that we have to trim everything because it has to be a closed loop. Something like that. And now I have to adjust the height. So if I go to the right view, I select this yellow stuff, make it all the way up, and then I want to go downwards to the following level, that is this one. Before finishing the model, I have to cut the topography, the void, and finish. It's okay. If that happens, is that I have to go a little downwards, okay? Because I don't have a flat surface here. So in this case, my level, instead of -12, I'm going to move it up, move it down, sorry, like 2 feet. See what happens. Then that will be -14. And we go. And then I have to select the void that I have just created. I have to select the void. If you press tab, you end up selecting the void. Edit in place. I select this. And now I have to go to the right view again. And I have to move it to the next level, which is this level -14. Oh, it's already done. Yep. It's not what I wanted to do yet. Okay, so that's my fault because I didn't calculate well the levels, but I'm going to do it again. I select the void, edit in place. Select it again. And now I'm going to make sure that I cut the topography. You see that I'm not cutting the topography here. So I want to drag this down to make sure that I cut this topography. And then I will adjust the level accordingly. So now I'm sure that I cut the topography. In the wireframe, it's here. And well, I have a level here, and that is, oh, the level -14. Yeah, so that's the right level, but I didn't drag the void until the level -14. So basically, that's what I want. Okay, so I want a real difference between no, joder. I selected the wrong one. That's the right one. Editing place. Okay, so that's the one I want to select. And that one has to go to level -14. There you go. Good. Okay, so that is the level -7, or I think, and this is the level -14. And I have this. This is where the ramp will start. Okay, two different levels. The difference between this one and the other one is I have to do some math, but not that much. So the difference between this one and the other one is 7 feet. So first, I'm going to create the staircase. Okay. To create the staircase, I think I did that that reference plane stairs. Okay, so that's why I lined up these two staircases, because I want to use the same reference plane, the reference plane stair. The reference plane stair. How can I do that? Always from the 3D view, because I have to work here. Okay, so I have to start the staircase here, and I'm going to use the section box. Remember that if I use the section box, I want just a section here. And that's the plane in which I want to work. Okay. Now, I want to create a solid model in place, but if I'm working with Toposolids, I'm going to work with the Toposolid thing. And now I want to create extrusion. I have to set the work plane at the reference plane stair. And now I can go down. I think we agreed that it was like 7 feet and 7 inches and 1 foot. And now we go 7 inches down and 1 foot. Then I can copy. All the way down. And I can stop here because here I have the following level. I continue this line in this direction. I trim this and this, this and that. And now, oh, there's a tiny gap here that I didn't copy well. I think it was my mistake. I'm going to continue, and I'm going to select all this and move it slightly up. Right. This is not closed. We have to be careful with that because it has to be a closed loop. And if it's not perfect, it won't work. Now it is perfect. And now I can extrude the stairs. Where? Extend the scope, the section box again. And now we have to extrude the stairs up to this point. Okay, so now we go down with the right steps. Now we have to do the same thing with the ramp. So with the ramp, it's going to be more difficult because the ramp slope, it has to be in 1 to 12. You remember that? The slope is 1 to 12 because people with wheelchairs, they need to go up, and more than 1 to 12, it's too steep, and well, you can't make it. And we need a landing. It's important that when we are working with ramps for people in wheelchairs, we need a ramp. We need landings because poor people have to rest from time to time. Okay, so we cannot have like 100 feet without a landing, even with a gentle slope, because it's gonna be too difficult for them. Okay, so this usually works. We have a ramp going up, then we have a landing, and then we change the direction, and we have a ramp going in a different way. We will need railings and all that stuff, but so far we're worried about the slope. So that's okay. I like this. So the maximum length without landing is 30 feet. Easy to remember. Okay, so for people in wheelchair, 1 to 12 is the maximum slope. The maximum length without landing is 30 feet. Okay, so with these two parameters, we can, we don't need anything else. So let's go back to this. We have 7 feet from this level to that level. So if the slope is 1 to 12, I'm going to do it with a PowerPoint. If the maximum, and we have constraints, the maximum length, it's 30 feet. And 1 to 12 means that if we want to go up 1 foot, then we need to, the horizontal is 12 feet. Okay, so if I insert the text now, if this is 12 feet, the distance that I can go up is 1 foot. $12 and 1. So if the maximum horizontal distance that I can go up, or I can go horizontally, is 30 feet, what will be the length of, or sorry, the height of this one? What is this height? 2.5. Are you sure? Yes. Okay. 12, 1 foot. 24, it would be 2 feet. 6 feet more, it's a half. Yeah, you got it right. Perfect. So this is 2.5 or 2 feet and 6 inches. That's a rule of thumb. Great, Charles. Thank you. So just remember this, you are designing a ramp for people with wheelchair, 30 feet, 2.5. And well, we don't have to remember, you can write it down or you can memorize it or whatever. But that's the slope that we need to do. 30 feet horizontal, 2.5 feet vertical. So what does it mean in our Revit file? So in our Revit file means that I have 7 feet So 7 feet, I need 2.5, and 2.5 is 5, and 2.5 is 7.5. So I'm going to need like 3 different parts of 30 feet each. So let's do it. But first, I want to create this reference plane because this reference plane is tilted. I can't use this one or I can't use that one. So I'm going to use a tilted reference plane. So let's go to architecture, reference plane, and I'm going to create that tilted reference plane. And I'm going to call this ramp angle. I know, something that you can remember. This is the ramp with the angle. And now on our 3D view, I can use the section box like this. And I'm going to work in that plane. Okay. So let's see how we can do it. Let's go to architecture, component, model in place. Let's go to a Toposolid. And we are going to select extrusion and the set plane. It's the ramp, ramp angle. This is the plane that, and now we are drawing in this direction. Okay. So I have to go down 2.5, 2 feet and 6 inches. Then horizontally, I have to go 30 feet. 30. Okay. And now that's the slope. Then I need a landing. What's the landing? Well, minimum, it's not, yeah, let's make it 6 feet. It's a good landing. And then I have to do the same. I have to go down 2 feet and 6 inches. Then I have to go 30 feet in this direction. And then the slope. Okay. I have auxiliary lines here. And okay, it's not done yet because I need another landing, a horizontal one, 6 feet. And then I go all the way down. And I'm going to close that loop here. And now what I need is the outline of the slope. Those were reference lines, useful reference lines, but now I don't need them. So this is what I have to draw. Okay, so I started here. We have that slope, landing 6 feet, another slope, landing 6 feet, and then I go all the way down and I close that loop. If I click OK, I hope it works. Yes, it works. And now I only have to adjust the thickness of that ramp. But we are not on that level first. Okay, yet. I mean, sorry. We're not on that level yet. So I need another ramp to go from this landing to this lower level. But that's the way. This is a safe ramp that meets all the requirements for safety and for accessibility. And it's quite easy. 30, 2.5. But first, I want to go from this point to the to that level. And I have a distance here. I don't know what that distance is, but I don't even have to do any math. Okay, so let's do it again. Let's go to architecture, component, model in place, Toposolid, extrusion. I set the work plane where the ramp angle is. Okay, and now I know that I have to go from that point to that point, from here to the to that level. If I go this, okay, it's 2 feet. If I have to go 2 feet down, what's the horizontal distance? 24. Perfect. If someone don't see that this is 24, please raise your hand and I'll explain it. But this has to be 24. And then I do this. I did 25. Well, everything that is more than 24, it's good. If it's 25, But I want the landing too. I want to do this and that. And now I delete this line here and I create the trim. And if this works, okay. Now from the top view, I have to adjust this side here and the width, the same. There you go. So this is the safe ramp going up. Okay, so I'm here at this level. I can go upstairs. If I have to use a wheelchair, I have to go this ramp. I have a landing, another landing. I go up, another landing. I go up, and I arrive at the different level. I want you to do this because you have to be aware of the length of ramps. Sometimes we have two levels and we say, let's put a ramp. Well, a ramp. If we want to go up 1 foot, this is 1 foot, we have to use 12 feet horizontally. If we want to go up 7 feet, we have to use a lot. Okay, so that's why sometimes it doesn't work in just one direction and we have to go around because otherwise the ramp will end here. And if we don't have enough space, then we have to do this. Is it safe? Well, not yet, because what if we don't have any railing here? I can fall, and well, this can't happen. So what did I say about the Revit railings?
I use them a lot.
That I love them. Okay. Yeah. But today we are not going to use Revit railings. So we're going to do our own railing. And as you can see, where is the danger? If I'm here, I can fall. If I'm here, I can fall. And I can fall to the stairs. So I need a wall that goes all this way up to this point of the ramp. And that wall has to start on this level. Okay, so I need to, the wall base is this level, and this level in my drawing is -14. I don't know in your drawing, but in my drawing is -14. So let's do it. Architecture, wall, level -14. And the outline of this wall is this. There you go. And now I have to adjust the height, okay, because it's too high. What's the height of a railing? The minimum?
48.
What?
48 inches.
48 inches, 4 feet.
And the ocean.
The bloody feet, I don't know. Height of railings. 36. But again, 36, 44, 36 for residential buildings, 42, sorry, for commercial. This is the minimum. So 44 would work, okay? Or 48 will work. But well, let's keep it 42, kind of. And yeah, but this is too high. And so the base constraint is -14. And then the top constraint is unconnected. And what's the height? I have to go up 7 feet plus the height of the railing. And how much is it in feet? 3 or 36 is 3 feet? Yeah. Okay. So then this height has to be 10. There you go. Okay, so this is a 3 foot railing, 36 inches. We can make it a little higher or taller, it doesn't matter. Okay, so now we are not in danger because if I'm here, I have a railing, I can go downstairs. I would need a railing here. And that's the only railing that we can use in Revit, but not today, because today we are dealing with topography. When we are dealing with buildings, we will use safety railings. But I'm not very happy because I think I can do better. We always can do better. And I'm going to adjust the shape of this wall to the slope. Yeah, to the slope of the slope. Yeah, it's redundant, but that is it. So now I'm going to edit profile. If I want to change the shape of a wall, not the layout, but the shape in the elevation, I have to use this edit profile. So on this profile, somehow I have to follow. You see that when it's parallel to the slope, I have this snapping point. Okay, so that's parallel to the slope. What? Constraints are not satisfied. Why the hell is this? I'm going to do it again. From this point, following the slope, and then I go to the railing again, and following the slope, I trim, and I have a nice wall following the ramp. Okay, so now I think that's great because I have 3 feet of the railing all along the ramp, and yeah, I think that's the right way to do it.
Can you show that one more time? I got the ramp. I mean the wall. I just want to make it follow the ramp.
Okay. Yes. Select the wall. Edit profile. Okay.
Select the wall.
Edit profile. You find it?
Select the wall.
Select the wall. Edit profile.
Yes.
Okay, if you edit the profile, we have to remove this line here. And then we have to try to, from this point, we have to go with the same at some point. Yeah, so here we have the slope is highlighted. So we know that we have the same. Then this has to be horizontal. And then we have to follow the slope again and trim. You get it? Okay. I'm going to finish this and then I'll be with you if you need any help. Okay. Because we are not safe yet. If we arrive at this landing, imagine that the brakes are not working and it can't happen. So I need another railing here. So I need to protect this part of the slope with another railing here. So let's do it. I need another wall from level -14, and then I'll adjust the height, but I need another wall here. And what's the height now? Okay, it's too high. This has to go. I think that landing was at 2 feet, 2 plus 3, it's like 5. So this unconnected height, it has to be 5. Yep, it looks good. And now this one, well, just for the sake of doing it again, I will edit the profile of this wall. Okay, so edit the profile, delete this line, and just from this point, we have to follow the slope. Oh, we have a landing first, sorry, and then we follow the slope. There you go. Okay, so it's maybe more difficult than we expected. Well, it's not. But if you can do this in Revit, this is the most difficult thing that we can do with the topography in Revit. We have a topography, we have